Good day, folks. Welcome to my YouTube channel. What are we going to look at? It's paper 2, November 2023. I'm going to look at the question 5, which is the rate of reaction. The most part that I'm going to focus on is the stoichiometric calculation. It says the reaction between excess dilute hydrochloric acid and sodium thiosulfate is used to investigate the factors that influence the reaction rate. We have a sodium thiosulfate and the hydrochloric acid, sodium chloride and sulfur and water and sulfur dioxide is formed there. It says the concentration of HCl is used is 1 mole per dm3. The same volume of HCl is used in each run. So now it says the time taken for the cross to disappear on the paper under the flask to become invisible is measured. So here, guys, in this conical flask, there's an acid and a sodium thiosulfate, and then there's a white paper that is written a cross there. There's a cross under that. So as this reaction progresses, it forms a precipitate here, a white tuberty. We call it a tuberty. It forms a white precipitate. That white precipitate, it covers the cross. So we, in this reaction, there's a time that is measured how quickly the cross is covered, how much time it takes for the cross to become invisible, right, by that precipitate there. So guys, we have 3 runs here. It says the table summarizes the reaction condition in the experiment. So guys, if you look at experiment 1, this is the volume of the sodium thiosulfate, and then here what happened, this is the what happened there. It happened in this volume and there was no water added, which means it was not diluted or the concentration was not changed. So guys, if you add water in this, that means you are changing the concentration, because from C is equal to N over V. So if you increase the volume of solvent, the concentration of the solution will decrease. So the concentration is that one, right? This is the volume that was there in run 1, and that with no water, it took what, 20.4 seconds. But in run 2, the initial concentration is this, but they used a different volume. So this is a C1, this is going to be C1, and then this is going to be V1 for run 2. And then the volume, the water that is added there is going to be this, right? The water that is added there for the solution 2 when it's diluted, so it's 10. So that means the concentration is going to decrease from this to that, right? Guys, so the volume, the V2, it's going to be 50. It's going to be this, right? And the initial volume is going to be 40, right? And V2 is going to be this 2, because in this initial concentration, the volume, it was 40, and then you added 10, it's going to make 50. The volume is going to be 2, and then this is the concentration, it's C2. This is C2, right? And then in the third run, they use the volume of 30. So the initial concentration is going to be always that one, and then the V1. So in run 3, this is the initial concentration, and this is going to be V1. And then the V2, the second volume is going to be this. It's going to be 50, right? It's going to be 50. I hope I make sense. Right, so what we're going to do now, I'm going to show you how we are going to calculate. Okay, let's answer the questions, but the other questions are very simple there, right? 5.1, we leave 5.1, and in 5.2 it says write down the independent variable. The independent variable is the factor that has been changed there. So by adding water in these runs, that means you are changing the concentration. So the answer there is the concentration of what? Concentration of HCl, right? um, the concentration of HCl. No, not the concentration of HCl, guys. We are changing the concentration. We are changing the concentration of the sodium thiosulfate, not the HCl there. So by adding water, we're changing the concentration of this. So concentration of sodium thiosulfate, right? Guys, another thing in this question, what makes the precipitate there? It's this sulfur. This is the one that is responsible. The formation of this, it makes the precipitate there. Right? Now in 5.3, it says calculate the value of P. So we want this concentration of this. The concentration of the third run, which is the final concentration, is going to be our C2, right? It's going to be our C2. This is what we're going to do. This is going to be our initial concentration, and then P is the final concentration, and the initial volume is going to be that, and V2, which is the final volume, it's going to be 20 plus 50, which is 20 plus 30, 20 plus 30, which is going to be what? 50. That's the volume we have. So the way we're going to calculate, forgot to erase this. I did the question before. So the way we're going to do this, we are going to use the dilution formula. The dilution formula is, this is 5.3. So it's going to be C1 V1 is equal to C2 V2, right? So what is our initial concentration? It's 0.13. The initial concentration, it's 0.13, and the initial volume, we take the volume of the run, the initial volume, the one that is not diluted. So it's going to be 30 equal to, we are looking for the concentration 2. The C2 is P now. The C2 is P. We're going to just substitute P and times by the V2. Remember the V2, I said it's going to be 50. It's going to be the initial plus water. So it's going to be 50. So when we divide by 50 there, we divide by 50. The 50, so P, which is the second concentration, it's going to be 0.078 mole per dm3, right? I hope I make sense, guys, by that. So now, guys, let me prove it to you before I proceed with the questions. Let me prove it to you. How can we prove this concentration? This is 0.1 concentration, this one, right? So the way we're going to do that, guys, I'm going to do it here. It's C1 V1 is equal to C2 V2. So we want to prove this concentration here. So what are we going to do? Our initial concentration is going to be, for the first run, it's going to be 0.13, and the initial, it's going to be 40, right? It's going to be 40. So we times by 40, since we are proving for run 2. And then for we're looking for C2, which is the concentration. But for the second volume, it was the initial volume plus 10, which is going to be what? 50, right? It's going to be 50. So let me punch that in the calculator quickly. So when I punch that in the calculator, um, it's going to be 0.13 times by 40, and then divide 0.13 times by 40, and then we divide an answer by 50. So the answer here, which is C2, is equal to 0.104, but they round it off as it's 0.10, right? That's the answer there. That's how it was calculated. That even you can prove even that one, how it was calculated, that concentration. Let's move to the next question, which is 5.4. 5.4, it says when 0.21 of sulfur, which is this one, sulfur is formed in run 1, the cross become invisible. Remember, I said it's the sulfur, which is the S, that is responsible for the invisibility of the 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 cross. Now the question, it says calculate the average reaction rate with respect to sodium thiosulfate. So we wanted the average rate of sodium thiosulfate. So now, if we know, guys, if you're noticing, all these questions of most questions of the stoichiometric questions in the rate of reaction, most of the time it has to do with rate, right? What is formed and what reacted. So if you just stick to the questions and make sure you practice these questions, you get used to them. So guys, they wanted the rate of the sodium thiosulfate, and we're given the this one, it was formed, right? So we're gonna do the ratio of what is formed and get what it was used, and then we do the rate. So what we're going to do, it's 5.4. So we're gonna change that mass to number of moles of sulfur. So it's number of moles of sulfur, which is the what is what formed, is equal to mass over molar mass, which is it's 0.21. Am I right? Yeah, 0.21. 0.21 we divided by what? By the mass of the sulfur. The mass of the sulfur is 32. It's 32. And then the answer will be 0.0655. As a marker of 56656 mole, right? So I'm gonna do the mole ratio now. The mole ratio of what is formed and what reacted, or what is used. So the ratio between them is 1:1. So I'm looking for the number of moles of sodium thiosulfate reacted or used is equal to the number of moles of what? Of sulfur formed. So the ratio is going to be, it's 1 times, because the ratio is 1:1. So it's going to be 0.00656, right? Moles, right? Right, now that we have the number of moles of what is used or what reacted for sodium thiosulfate when it reacted with an acid, now we can change now the number of moles into what? Mass. So we can say number of moles is equal to mass over molar mass. So it's going to be 0.060656. The mass of the sodium thiosulfate, guys, we have to calculate it. I don't know by heart. It's a sodium, which is 23 times 2, plus the sulfur is 32 times by 2, and then the oxygen, it's 16 times 3. So when we cross multiply that, the mass of the sodium thiosulfate, it's going to be the answer there is going to be it's 1,04 grams. Now that we have that, we can calculate the rate now. We can say rate is equal to, we were told our rate, it's supposed to be grams per second. Do we have time? Yes, they said for run one. The time for run one, it's 20.4. That means we're going to use 20.4 there. So the rate is going to be change in mass over change in time, which is it's going to be 1.04 divided by what was the time? 20.4 divided by 20.4, and the answer there, it's going to be 0.051 grams per second. That's our rate there, right? So that's the answer there. Guys, I'm not gonna answer these questions. They are straightforward and easy. I'm gonna leave them. Cheers, bye.